Hi everyone, how are you? How's everything? I hope everything is going well and Ramadan Kareem, and hope you're enjoying the holy month of Ramadan with your families. I would like to continue regarding the Laplace transform that I was explaining for you before. And if you remember, in the last video I asked you to solve an example for me, which was this one. If f of t is 10 e to the power of minus 2t cosine of tut, I had asked you to find the f of s, means the Laplacian of this function. As many of you found it correctly and sent it to me by your email or showed it to me in class, f of s will be simply 10 times s plus 2 over s plus 2 square plus 4 square. But why? Let's take a look. Cosine of 4tut, only this part. You can tell that this part, if you follow the formula for the cosine of omega t, of course, the Laplace transform of this one should be s over s square plus 4 square. But what has been added to this? This one, e to the power of minus 2t. When we have e to the power of something in time domain, it means that we're going to have a frequency shift. What is going to be the shift? This, minus 2. And if you remember, in the frequency shift, we flip the sign. So any s that we have in the body of our function in S domain is going to be changed into s plus 2. That's what we see here. So before, for cosine of 4t, it was s over s squared plus 4 squared. Now, when it's being multiplied by e to the power of minus 2t, any s becomes s plus 2. So it will become s plus 2 over s plus 2 square, 4 square. And of course, it's being multiplied by 10. So the answer will be 10 s plus 2 over s plus 2 square plus 4 square. If you want to expand it one more level, it's going to look like it's 10 times s plus 2 over s square plus 4s plus 20. Now, I want to solve another example for you. But before that, let me remind you something. If you go back to the Laplace table, to the properties, one thing that you will learn is that if you multiply a function by t in time domain, in S domain, the answer will be the derivative of the f of s. And it works the other way around too. If you want to find the derivative of the f of t in S domain, you just multiply it by s. So it works also for higher levels of differentiation. So it means in time domain, if you multiply your function by t to the power of n, in S domain, your answer will become d to the power of n over d Sn. It means that the nth derivative of f of s. So this is also available in the Laplace table. So now why did I remind you this property? Because I want you to solve this example for me. Imagine your f of t is 20t e to the power of minus 2t sine of 40 ut. So let's think about it step by step. Sine of 40 ut, of course, the Laplace transform of this is going to be 4 over s squared plus 4 squared, because omega is 4, and you remember that the Laplace transform of sine of omega t was omega over omega squared plus s squared. So sine of 4t will be, the Laplacian will be 4 over s squared plus 4 squared. But here we have multiplication by e to the power of minus 2t, just like what we just solved. You remember, this one is a frequency shift. It means any s that we have is going to be shifted by 2. Any s will become s plus 2. So the answer will be 4 over s plus 2 square plus 4 square, which is 16. But it's not done. It's also multiplied by t and also multiplied by 20. Multiplication by 20 is simple. We just multiply here by 20. So here it will be 80 over s plus 2 square plus 16. But what about multiplication by t? Going back to the property that we just talked about, we have to find the derivative of what we have found so far. So we have to find the derivative of 80 over s plus 2 square plus 16. And the derivative of that will be this one, 160 s plus 2 over s plus 2 square plus 16, everything to the power of 2. So this one will become the Laplacian of this f6 of t. How about finding the Laplacian of 6 cosine of 4 times t minus 1 ut minus 1? This one is a time shift, right? T has become t minus 1. When t is becoming t minus 1 in S domain, we have to multiply it by e to the power of the shift. Shift is minus 1. So we have to multiply it by e to the power of minus 1s. Because you remember, when we have a time shift, it keeps the sign when we want to multiply the s side by e to the power of something s. But the other way around, for the frequency shift, the sign was being switched. So let's think about it without the shift. So if we had 6 cosine of 40 ut, the answer would have been s over s square plus 4 square, right? But now it's shifted by minus 1. It's being multiplied by e to the power of minus s, as you see over here. And of course the 6 is there. So for the final answer will be 6s e to the power of minus s over s square plus 16. How about this one? We want to find the Laplace transform of h of t equals 6 sine of 3t plus 8 cosine of 3t ut. So one by one. It's linear, right? So for 6 sine of 3t is easy. It's gonna be 3 over s square plus 9. First time 6. And for this one, also easy. 8 times s over s square plus 9. So since they both have the same denominator, s square plus 9, we can add the numerators together. So it's going to become 8s plus 18 over s square plus 9. So as you see, Laplace transform is super simple, and you will also be provided by these two tables. One of them is the Laplace transform table for most important functions, and the other one is the properties of the table of the Laplace transform. So as you can see, all the properties, linearity, time shift, multiplication by t to the power of n, frequency shift, everything is explained here, and the formulas are given to you. And here you have the Laplacian of all important functions that you might need to deal with, mainly the signals that you always get from your power supplies are not out of these functions. If it was out of these functions, it's something that you can use the properties to find it, because it might be the linear combination of two of these functions or something that you can always find the answer using this table. I hope you were not bored and you got the basics of the Laplace transform so far. I'm gonna come back to you with more examples and with more new subjects. Enjoy the rest of your day, have fun, take care, and see you in class.